Our topic is triangularization, and let us compare this with diagonalization. Diagonalization. So, what is diagonalization? When you have a matrix capital A, you want to find a new matrix capital P, which is non-singular, so that P inverse into AP is diagonal matrix. In the same way, when you have a linear operator phi, you want to find a basis, and when you want to find basis, you want to say that when you find matrix representation of phi with respect to B, it is a diagonal matrix. So this is the definition of diagonalization. Now now the thing is, when you have this capital A, you know how to proceed, how to find P. You find eigenvalues, you find eigenvectors. If you have sufficient vectors that you are able to make matrix capital P, only then it will be diagonalizable. Otherwise, if you are short of eigenvectors, then this P will not be made, and then this A will not be diagonalizable. In the same way, when you have phi, you will find eigenvalues, then eigenvectors. Then if you get, for example, this phi is from R cube to R cube, and according to definition, we need a basis of R cube, and basis of R cube contains three elements. Now, if you have three eigenvectors, only then you will be able to make the basis. And if you have less than two eigenvectors, then obviously basis will not be made, and you say that this phi is not diagonalizable. Now, in the same way, you have capital A. You have capital A. When you have capital A, you say we want to find a new matrix capital P. When we want to find new matrix capital P, we only want to find P inverse AP, and when you check this P inverse AP, it is a triangular matrix. It is a triangular matrix. That's it. So in the same way, you have this phi, and you want to find a basis B, so that when you find phi B, it is also a triangular matrix. Now, what a triangular matrix is? A triangular matrix is when you have this diagonal, for example, and something is present here, but 0 is on the other side. So, for example, you have 1, 2, 3, 4, 5, 6, 0, 0, 0. This is a triangular matrix. Okay. So, we want to do this now. This is a remark. Remark says, whenever you have a square matrix capital A, and whenever you have a linear operator phi, we know that it may or may not be diagonalizable, but when you have A and phi, will always be triangularizable. Will always be triangularizable. So how to proceed? Algorithm for triangularization, and at the same time it is a theorem also. You say that prove that for a matrix capital A, we can find matrix capital P, so that P inverse AP is a triangular matrix. Now, what happens is, you start the theorem, proof. See, this proof gives us the algorithm for triangularization. Now, you say let capital A be a square matrix. Okay, be a square matrix. Fine. And lambda 1 be eigenvalue with corresponding eigenvector x1. Okay. So according to definition, you have Ax is equal to lambda 1 x. Clear? Now what I do, A1 Ax1 is equal to lambda 1 x1. Now what I do is I say this is the most important step. This is the thing which is important. You say that we extend x1, we extend x1 to x1 x2 up to so on xn. You have to find only one eigenvector. When you find only one eigenvector x1, add x2 x3 xn as you like, and you make this matrix. For example, this matrix is M1. I'm writing say. Fine. Now, what you do, you say this is A implies now A into M1. A into M1 is, what is A into M1? It is like A into X1, X2 up to so on Xn. Okay, and what is this? This is this will become Ax1, Ax2 up to so on Axn. Now Ax1 is lambda 1 x1, lambda 1 x1. Then you have Ax2 up to so on Axn. I think this thing is clear to you. Now next step is if you take this x1 x2 up to so on xn out, okay, this thing will become lambda 1 0 0 0 0 up to so on, up to so on 0. First column will become 0 and something will be here, doesn't matter, and then b. So this is n minus 1 cross n minus 1 matrix. Now what I am saying is, for example you have a 3 cross 3 matrix. Okay, you have a 3 cross 3 matrix. 3 cross 3 matrix will have 3 eigenvalues. We are not taking care of 3 eigenvalues. We are using only one eigenvalue, for example lambda 1. Corresponding to this lambda 1, we have x1. When we multiply this A by x1, it will become lambda 1 x1. So, when I use this result by making a matrix x1, x2, x3 is equal to m1 say, then this thing will become lambda 1, and all those two elements below lambda 1 will become 0. On first column anything can be present, I don't need that. You see, this is your diagonal, it will contain eigenvalues, lower portion will be 0, and on the upper side whatever you have, you don't care. Okay, so you have this matrix B is 2 cross 2 now, because this is 3 cross 3. Now next thing is, now take B to let lambda 2 be lambda 2 be eigenvalue and corresponding eigenvector x2. Okay, x2. So you say extend this to make matrix n2. Okay, to make matrix n2. This is your matrix n2. It contains x2, x3 up to so on xn. But I am saying in this, I am saying that you have this matrix B. B is a 2 cross 2 matrix. It will be having one eigenvalue. We consider it lambda 2. Now you have lambda 2 and x2 is corresponding eigenvector. Now this is 2 cross 2 matrix. So if you make n, it will be consisting of only two vectors x2 and x3. So you make x2, x3 up to xn. This is n minus 1 cross n minus 1 matrix. You know this. I think this is clear to all. This is n minus 1 cross n minus 1 matrix. Now you say extend this to m2. M2 is equal to 1, then 0, then 0, then n2. What is it? This is a n cross n matrix. So you say that you multiply this am1 with m2. Okay, with m2. When you multiply this, it will become, sorry, one step I forgot to write. I think I should bring, okay, this is m1. Okay, this is m1 into lambda 1 0 0 up to 0, then this is star, then this is b, then you multiply it by m2. This is m2 1, then 0, then 0, then n2. I hope this thing is clear to you. So you have a m1 m2 is equal to, now m1 I am not dealing with m1. This is one, this is one star, and this is one column, sorry, this is one row, one star up to so on. This will multiply with this thing. It will become lambda 1 into 1 plus all other elements are 0. It will remain lambda 1. Now this is 0, it will remain 0. Okay, this is star, it will remain star. This b will multiply with n2. Now in the rough side, if I multiply b with n2, this is b into x2, x3 up to so on xn. You see it will become lambda 2, then star, then 0, then some C matrix. I think this is clear to you. See, when you had this m1, you multiply it with a into x1, x2 up to xn, it becomes this thing. Okay, it becomes this thing. Now, if you multiply b with the same kind of a structure, what it should look like, you can directly write. It will look like m1 into m2 will come out lambda 1, lambda 2, 0, 0 up to so on all 0, 0 up to so on all 0. Then you have star, then you have C. This is n minus 2 cross n minus 2. So this is your theorem. So you say that continuing so on. You say that, so you say continuing so on. Continuing so on, we will get m1, m2 up to so on mn. See, you have n cross n matrix capital A. It will be having n eigenvalues, whether distinct or same. You know this. When you are not using all eigenvalues at the same time. You are taking one eigenvalue, making a matrix, then multiplying it. Again, you find a smaller matrix B, then you find one more eigenvalue, one more eigenvector, you multiply it with make m2 and then multiply, so and so and so. How many steps will you have to take? You will have to take n steps, m1, m2 up to so on and mn, and it will become a m1, m2 up to so on mn is equal to, okay, is equal to m1, m2 up to so on mn is equal to m1 m2 up to so on mn into lambda 1 lambda 2 up to so on lambda n. This is 0, lower part is 0, upper part is star. I hope this thing is clear to you. Now you say this is a into p is equal to p into this thing lambda 1 lambda 2 to so on lambda n 0 and star. Okay, and then you bring this p on the other side, it will become p inverse ap is equal to this. I hope this thing is clear to you. See, in this theorem you say that you have to go to m1 m2 up to so on mn. In many cases, rather in most of the cases, when you are dealing with the numerical, then most of the time your question is complete in even 1 or 2 steps. Okay, we will do a question. In this book only two or three numericals are given, so I request you all to go through your old question papers and see the triangularization related numerical problems and solve them. I will take one solved problem from your book, and this says that this is 1 minus 2 0, then you have 1 minus 1 2, then you have 0 1 1. Fine, this is a matrix capital A. Now what you do is step 1, find eigenvalues. When you find eigenvalues will come out to be 1 1 and minus 1. Fine. Now you take for lambda is equal to 1. You can take lambda is equal to minus 1 also, but always take that eigenvalue which has algebraic multiplicity more than 1. Okay, it will be easy to do with that eigenvalue. You have for lambda is equal to 1, eigenvector is it is given to be 2 0 and minus 1. Okay, or you can write 2 0 and minus 1, doesn't matter, 2 0 and minus 1. Now you want to find matrix m1. Step 2, to find matrix m2, sorry m1, to find matrix m1. When you want to find matrix m1, okay, what you do, you have 2 0 1. X1 you already have. If you remember the theorem, x1 you already have. You have to add two more vectors, and when you add those vectors you have to add two vectors or two columns in such a way that this matrix m1 is non-singular. See, if you remember, I wrote m1 a into m1 m2 up to so on mn is equal to m1 into m2 up to so on mn into some matrix. Now this thing will come on the other side. If it come on the other side, it will be in inverse. If it is in inverse, then inverse should exist, so m1 inverse should exist. So when you add these two vectors or columns, you should add in such a way that you are sure that this matrix that you have formed is a non-singular matrix. Okay, so the best way is always think of a matrix of this form. Okay, i.e. this is this is a triangular matrix, and you know that when this is a triangular matrix, determinant is product of diagonal entries. When you find the product of diagonal entries, it will be 2 and it is non-zero, so the matrix is non-singular. Okay, so you to find matrix m1, so what you write, you say we extend x1 to m1 is equal to x1 x2 x3. Okay, in such a way that, say, okay, here m1 determinant is non-zero. This is most important. Okay, this is most important thing. You say we add two columns in such a way that determinant is non-zero. Now the thing is, you find M1 inverse. This is the difficulty in this numerical, that you have to find matrix, then you have to find inverse, then you have to multiply also. This is the only thing that I don't like about this method. Otherwise, this method is easy to apply. And when you find M inverse, it is given to be 1 by 2, 1 to 1 0 0 0 to 0, and then 1 0 2. So this thing is given. So this is minus 1, sorry, minus 1 minus. Okay. So this is your M inverse. Fine. Now what we do? We multiply M1 inverse into AM1. In this way, we multiply. When we multiply, now see, you have to multiply these three matrices. This is 1 by 2, 1 0 0, then 0 2 0, then 1 0 2, and then you have A is 1 minus 2 0, 1 minus 1 2 0 1 1, and then this is 2 0 0 0 1 0 minus 1 0 1, in this way. So you multiply this. When you multiply, your answer will be 1 minus 1 0, and then 0 minus 1 and 2, and then 0 0 1. So you should observe that this is 1 minus 1 and 1, then this is star, and this is 0, which is this is capital O, which is a triangular matrix, okay. So you see, you had to find only matrix M1, and when you multiplied this matrix M1 with this given matrix, just in only one step, this become a triangular matrix, okay. So this is the thing, when you do the numerical, in most of the numerical, the question is complete in 1 or 2 steps only. You do not have to go up to 5 or 6 steps. Numerical is given to be this is 1 minus 3 3, 0 minus 1 and 2, and 0 minus 3 and 4. I again request you to fetch all questions of see, in your unit 2, this unit is particularly easy because it has many numericals. First is that I am not saying all will come in your exam, but many will come. So first is diagonalization, second is triangularization, third is Jordan form, and fourth is canonical form. So Jordan form, rational canonical form. Jordan canonical form is most important. One numerical will surely be coming from this form. So you should understand this, and many times it happens that it comes in 16 marks also. But if it comes in 16 marks, then it is a 4 cross 4 matrix. Obviously, it becomes somewhat difficult to multiply those big matrices, okay. But still, if you know the method, you can attempt the question, but never attempt the question of Jordan canonical form or rational canonical form in the first go, okay. First you do all theoretical part, because theoretical part, you know that when you have a theorem, you know the fixed proof, okay. Here you are trying things, and a numerical is given, or it may happen that some numericals are given in your book when you go to exam, and some numerical appear from your book, and you know how to write, what to write in that numerical. I'm not saying you have crammed, but many a times it happens that when you have seen the proof or solution of the numerical, some things are in our mind, so calculation become easy. So for example, if this question comes, so it will be a bit easy for us, okay. At least we know that it will be complete in only one step after finding only one matrix M1. So this is your new question. This says this is your matrix A, and you need not find eigenvalue here. Why? Because see, when you apply this first M1, What is its function? Its function is to make 1 0 0. 1 0 0 is 1 is eigenvalue that you are considering, and it has to make 0 0 in the column. If you observe this matrix, you see that this is 1 and 0 0 is already present. Since 1 is alone present in one column, so you know that 1 will be the eigenvalue. What I am trying to say is, when you are trying to triangularize the matrix, you already have one column in the required shape. This matrix is star B. This matrix is star B. So instead of dealing with this matrix A, deal with this matrix B only, because this portion of the matrix is already in the required form. So you say in solution, you say first column of capital A is in required form. So we take matrix capital B is equal to -1, 2, -3, 4. Okay, and you find its eigenvalues and eigenvectors. So eigenvalues will be, it is given that the eigenvalues will be 1 and 2. And you take, for example, you take 1. Lambda is equal to 1. You find eigenvector. Eigenvector will come out to be 1 1. Eigenvector will come out to be 1 1. Now you want to find matrix capital N. If you remember, 2 cross 2 matrix capital N. When you find this matrix, it will be x1 x2. So it will be 1 1 0 1. Okay, you add one vector as per your choice, and when you add like this. So when you have n, you have n inverse also. This n inverse will come out to be like this. Fine. Then you want to find m, and you know m is 1, then 0, then 0, and then n1. Okay, so it will be 1 0 0 0 0 1 0 1 1. So this is your m. Then you need m inverse. M inverse will be 1 0 0, and then this is n1 inverse. So you say this is 1 0 0 0 0 1 0 minus 1 1. Now you have this matrix M. You multiply this matrix M inverse into A into M. So obviously you have to multiply this, then this, then this. When you multiply, it will come out to be, this matrix will come out to be, it will come out to be 1 0 3 0 1 2 0 0 2 in this way. So you say this is 1 1 2, this is 0, this is star. Okay, so obviously this is a triangular matrix. So the thing is, it could have happened that we do not see the structure of the matrix. We do not feel that this column is already in the required shape. So we need not deal with it, and we simply start doing for example, we find one eigenvalue, it will come out to be lambda is equal to 1. Then we find eigenvector, then we make x1 x2 x3 as m1, then we multiply it. We will get a matrix of similar format. 1 0 0 is already there, no need to deal with this. Deal with the rest of the portion, which is this. You deal with 2 cross 2 matrix. When you have 2 cross 2 matrix, find matrix n, then find n inverse, then find m, then find m inverse, then multiply. It will come out to be a triangular matrix. So you write which is a triangular matrix. So in exercise also, You have 2 or 3 numericals, please do them. And